Hello everyone, welcome back to my channel. Today we are diving into stock market analysis using Python. We will be performing a real simple stock market analysis with Jupyter Notebook, and we'll be looking at Apple's stock price, calculating moving averages, generating trading signals, and visualizing everything in a clean, professional way. So let's get started. Before we get started, just remember none of this is any type of advice, especially financial advice. So do your own research. So as I said, let's restart and run all. And we start with importing pandas, yfinance, just to get the data, Matplotlib and Seaborn. And we do some style for the plots. So the grids are nice and the plots are well figured. And as I said, what we'll be doing, we'll be analyzing Apple. So first we know we want the ticker, and the ticker of Apple is like this, AAPL. And we make a data frame. By the way, never name a data frame DF. People don't like it, but as far as we'll be working here just for examples, it's okay, name it this way. So download, and then we download the ticker here, AAPL. I'm just writing it this way, so I just can change it later for something else. So ticker, the start will be the first date of 2024, and the end would be the first day of 2025. And we copy just in case. Ta-da! And okay, it is now completed. Let's see how the head looks. The head should be the first 5. Quite good. We see the closing, we see the high, we see the low, that's during the day. Obviously, the 1st of January is a holiday, so we don't have data. Then we see low, we see open, we see volume. It's quite okay. So the head is here, and first let's take a look how the daily returns look like. Pretty much it's the closing from today versus the closing from tomorrow, or the closing for this day versus the closing for day -1, and how it changes in percentage. So we are gonna name it like this, daily return percentage, and it's gonna be DF close. If you want to see what DF close is, just click B here, press DF close, and you see we get the whole data frame here. So DF close times PCT change times 100. As simple as this one. And now if we do the DF head once more, we see the daily return, and we can see that the daily return for the 8th of January looks quite okay, 2%. It's probably a lot, I would say. Yes. Now let's try to plot it. So we have the figure. And it would be DF close, then plot, and then the title we would be using F because it would be used the ticker, and stock price. Can write the year, but in this case I'm not writing it because this one can be changed later. And I will also use color, and the color will be the nice color of royal blue. Okay, we need some labels. Price in USD, like that. And there is something called tight layout, and we're gonna show it. Let's see how it would look like. Okay, this is how the Apple stock price looks like for 2024. Probably started on 180, finished on somewhere on 250, roughly. To be more exact, it started on 184 and finished at, okay, it's head and probably tail, yeah, and finished on 250. Yeah, quite fair. That's good. Let's take a look at the distribution of daily returns, pretty much of this thing here. So we're gonna use pretty much SNS his plot, and it's gonna be daily returns in percentage, and we'll be dropping the NA, which is probably the first one. We'll put it in how many bins. 20 looks okay. KDE true, and the color would be green. And then we can always say POT show, POT tight layout, POT X label in this case, and the X label would be daily return in percentage. And some kind of a title, POT title, and this way as well, ticker, and it will be daily return distribution. Okay, and of course you didn't like something, SNS his plot df daily return dot drop NA, oops, yep. Something like this. Cannot assign to function call. I got it. It's this one here. And what it doesn't like now, invalid index error, daily returning percentage, daily return percentage, like this, daily return, of course. And this is how it looks like. Okay, what is interesting here is immediately with 20 bins, or even with 10, or with however we put, we see that there are days on which we get actually like more than 6% return on that stock, and there are days on which we get -4 and more. And the question is, how do you want to get these days? That's a really decent question, and for this one we'll be using from ipython.display import display, shift enter, great. And now here we'll be using with PD option context display max rows none display df, and it will be actually df sorted, and we are going to say df sorted would be df sort values. I'm just going to copy this one, not to mistake it somehow. Probably we can assign like a variable for it, and sending is false. Let's see what we're gonna get. Yeah, the width is like this, and this is it. We can see that in 2024 0611, which is somewhere on June 11th, something happened with Apple, and they had a huge daily return of 7%. And we have some of 5, 4, 3, but in general we usually have something like 0.5% per day, which is actually not bad, definitely not bad. As I said, none of this is any type of advice, so do not think of using it. I mean, do your own research. Now let's take a few strategies. There is something called 20-day and 50-day simple moving average, And the idea is that whenever these averages are actually crossing each other, then this can be considered a signal for a lot of people. I mean, does it make sense? Let's see. So what we can do is we're gonna call it SMA 20, which is SMA stands for simple moving average, and SMA 20 is 20 days, and we are looking at DF close. We take the rolling 20 and we take the mean, and we do the same with SMA 50. Yes. And now we can take a look at the DF. Okay, obviously some kind of a problem here. None, not a number. The thing is that we need 20 in order to have it. And the real truth is that we only have it 20 after the first 20 days are passed. So for the time being, it looks okay. Now let's plot the close and the SMAs. So DF like this, and we are interested in the close. SMA 20, SMA 50, and plot. Title is ticker moving average, ticker price average. Ta-da! This is interesting. So we have the closing date here of Apple, the closing values, and then we have the SMA 20, which is the simple moving average of the last 20 days, and the simple moving average of the last 50 days here. See that it starts like 30 days after here, and here we have such kind of interchange here, and here we have some others here, and here we have some others. The question is this like some kind of signal? It's definitely a signal. The question is what kind of signal it is. So let's try to generate the signal with saying 1, -1, and 0, and just repeating none of anything that I'm doing is any type of advice. So don't do anything based on it, just for fun, if you have it. So the idea here is we're gonna take the data frame SMA 20 if it is bigger than SMA 50, then the signal is equal to 1. So it means that if the 20, which is the orange, is higher than the 50, then it is 1, and if it is lower, it is -1. Yeah, makes sense. And in the general, it's 0. So let's see how it looks like. Okay, and if we want our thing, all the data, okay, we have zeros, we have -1s, we have 1s, we have -1s, and we have 1s. Quite okay, I would say. Yeah, so we generated the data. So let's try to plot everything as markers, and in order to not to waste your time, I'll just put a pause, and then I'm going to generate the code. So the idea is when we get the 1 here, which means that the 20 average is bigger than the 50 average, we have a 1. So the idea is that it is buy, and if it is -1, it is sell. And then it's called the 2050 SMA Crossover, and SMA is simple moving average. So let's run it, and this is how it goes. Okay, whenever we are here, we are on the sell, then we are on the buy, on the sell, on the buy, on the sell, and here on the buy. It's a question Would it make us money? It really depends on how much you buy, how much you sell, and as I said, it's easy once we have the data to make some analysis. It's tough before having the data making the analysis. So it's kind of playing lotto by already knowing the numbers. Yes, it's easy this way. Anyway, let's continue and let's talk about adding something as a second signal, calling the relative strength index as RSA. Which is actually a 14-day period to identify overbought and oversold conditions. And this one is rather complicated as well, so now I'm going to write it as well, not wasting your time, just stopping a bit. And now here is our RSI calculation. We have the delta calculated, taking from the close. We got the RSA signal, we plot it, and then we plot it like twice, the buy and the sell. And let's show what we got actually. So something looks not okay. Let's rerun everything. Because it shouldn't be like this. Yes, now it looks okay. The RSI 14, see, like over 70 means something like overbought, and below 30 looks oversold. So the idea is that whenever we are here, we should be buying. Whenever we are here, we should be selling. At least this is some kind of logic that we are having. I'll say it for the third time or fourth time. This is not an advice, but it looks interesting in a way. So we have it, and now let's think how to create the strategy combining both the strong buy and these buy signals and sell signals and these ones here. So whenever we are having something here, it means some kind of strong buy or a strong sell. And of course, I'm just going to generate it for you. So see you in a minute. So at the end, we have a data frame looking like this, which is pretty much here the data from Yahoo Finance, here the daily return, here SMA 20 and 50, and the signal SMA, which is -1 or +1. Here we have the RSI and the signal RSI, and here we have something called signal combined, which is pretty much saying that whenever our signal SMA or signal RSI is 1, then the signal combined is 1, and whenever it's -1 and -1, signal combined is -1. So it could be named strong buy or strong sell. Yeah, as I said, none of this is any type of advice. So we plot the combined signals using this marker, and plotting it once again, this is how it looks like. Okay, so here we sell, makes sense. Here we buy, doesn't make sense because we fall even more, and then we buy again, then we sell, then we buy, then we buy, and then we sell. In theory, looking at it, it looks okay, and in general, it's a good question whether it will work. I'm just curious as a summary to analyze something else, and the question is why not? Let's take Microsoft from 2020 to 2025, and Microsoft looks like this. Daily return, yeah, Microsoft is also going high. So in general, the time between 2020 and 2025 was rather favorable, so it will look okay. Yeah, Microsoft, you see here the mean on the 0, it's a bit to the right, and Microsoft even had days like this one, 2020, 13th of March, when the shares went 14% up. It's crazy for Microsoft. And then the moving price average looks okay. Then the signals are rather interesting. And then let's take a look at the combined one. Okay, selling, buying, selling, selling, buying. Well, in general, yeah, what I can say is always do your own research and never do something with money that you don't know what it is. But as I said, this is not an advice. So I'll say that's it. We've analyzed AAPL stock, plotted month moving averages, generating trading signals, and plotted even data from Microsoft. You can do it for a lot of companies, just taking a look at the history. And if you found this video helpful, smash the like button and subscribe for more Python finance content. And let me know in the comments what stock we should analyze next or what not. I mean, in general, I'm not analyzing any stocks. I'm just building some kind of simple tools with Python and Yahoo Finance that most probably if you copy them, you can improve them if you want. My idea is simply to understand how it works and hopefully to show some knowledge to the greater audience. So in the comment, let me know what you liked in the video or what you didn't like, and so far so good. That's all from me. Take care of yourself and goodbye.